Hello guys, my name is Shambu and my topic is transfer of RNA. Transfer of RNA constitute about 10% of the total amount of RNA in the cell. tRNAs were the starting point in the study of structure of nucleic acid. There are 20 families of tRNAs corresponding to the 20 amino acid. The secondary structure of various tRNAs is in the principle of the same type. This must be so for tRNAs molecule to perform their functions. The function is recognizing of the mRNA codon on the ribosomes and the amino acid into the protein chains. The secondary structure of tRNA may be depreciated on the basis of the possibility of pairing of the complementary bases adenine with uracil and guanine with cytosine, and assuming that the non-pairing protein loops. Secondary structure of tRNA can be found as shown by Eugene with the aid of game module. Rich in 1972 succeeded the structure of faint tRNA by means of X-ray structural analysis. The compact structure of tRNA is stabilized by horizontal and vertical interaction in the double helical proteins. Then my second topic is translation. Translation, which is the conversion of the polynucleotide transcript of DNA and mRNA into the amino acid protein text occur in the complexes of ribosomes with polyribonucleotide chains. Example in polysomes. Ribosomes can only be observed with the aid of an electron microscope and spherical particles with a diameter of 15 to 25 nanometer. The ribosomes of eukaryotes are characterized by a high value of S20, 80S and not 70S, and by molecular weight of 4.1 to 4.7 into 10^6, and by somewhat larger size. The dry volume is 5 into 10^3 nanometer cube. The 70S ribosome consists of two subunits, 30S and 50S. The molecular weight of 50S particles is 1.8 into 10^6, and that of 30S particle is 0.7 to 0.1 into 10^6. Ribosomes RNA constitute about 65% of the dry weight of ribosomes, the remaining 35% beginning proteins. The RNA is subdivided into three classes. First is 23 to 28 years, 16 to 18 years, and 5 years. By the help of measurement, we can understand the physical properties of E. coli ribosomes. First is sedimentation coefficient is 69.1 to 70.5. Then intrinsic viscosity is cm per cube by gram is 6.1 to 6.8. Then translation diffusion coefficient is 1.83. Then specific value in cm cube per gram is 0.64 to 0.60. Then molecular mass is 3 into 10^6. Then size in direct state is in nm is 20 to 17 into 17. Then volume is in nm square is 3 into 10^3. Then size in aqueous molecule is nm is 30 to 13 to 20. Then volume is nm cube is 3 minus 10 into 10^3. And then amount of bond water is gram per gram is 0.9. Then we learn about translation, the steps of translation. The translation start by the process of initiation. In initiation process, the mRNA transfers to the ribosomes, the cell's protein factory. A transfer RNA, tRNA molecules carrying amino acids through complementary base pairing. Translation beginning at the start codon, usually AUG codon for methionine. Then second process is elongation. tRNA molecules bearing amino acid to the ribosomes in sequence according to the mRNA codons. The ribosomes help form peptide codon bonds between amino acids, creating a growing polypeptide chain. Then last process is termination. In termination, when a stop codon is UAA, UAG, and UGA is reached on the mRNA and translation ends, the new protein is released and often undergoes further folding and modification to become functional.